Nice to see you all. Still here at the end of the day. Um, yeah, as has just been mentioned, I've been chairing the GSMA's fraud and security group all week, and IoT's come up repeatedly, as you can imagine, and every single industry in the world is now using IoT or wants to use IoT, and every single sector of society. And actually, the telecoms network underpins a lot of that. So my company, Copper Horse, has been involved in mobile phone security for a long time. We then got involved in transferring some of those defensive techniques into the IoT space. And along that way, we kind of collected cars as well, partly because of personal interest. I like fast cars and I'm interested in it. But partly because the vehicle, the car, is becoming this most mobile, literally, of all of our IoT products, and it's really becoming super connected with many different wireless technologies, and of course there's this big strive towards autonomy. And so one of the projects that we collected along the way, which was really an IoT project, because it was Innovate UK funded, was this secure CAV project. And so we got together a consortium of companies and universities. Originally, this was a company called Ultrasoc, who were then acquired by Siemens in midway through the project. And we had Coventry University there as well. So we were the sort of security people. Coventry University was sort of the automotive academics, and University of Southampton gave us their sort of software engineering and AI and ML skills. So we had this kind of great consortium of minds looking at how we could build the sort of tackle the security problems of tomorrow's connected and autonomous vehicles. I'm going to mention a bit about that as we go through, but I thought I'd just give you a little sort of tour of what's going on and what we see from our work and what we see the future challenges being. And we can't necessarily solve all of them, but once we start to talk about them, then we're sort of on the pathway to doing that. So actually, the history of car hacking, well, the history of tampering with vehicles goes right back to the start, really, if you think about the origin of how cars came about. But cars have always been stolen, and steadily the industry moved towards securing those with mechanical locks and so on, and then people would break into them and so on. When car stereos, as soon as they were introduced, were repeatedly stolen, and people have come up with various solutions for anti-theft. And even to this day, actually, there are still companies that are organizations that provide tools for breaking into the security of head units or infotainment units in vehicles. Actually, my own background, so I used to look at how people would break into embedded systems, particularly mobile phones. And the time that I started doing that, at the end of the 90s, we had a whole bunch of kind of bored hackers who'd come from the car radio hacking scene and moved into the SIM unlocking scene in the mobile phone industry. And then that kind of thing evolved into the whole routing and jailbreaking scene, which is coming full circle now and is back into the car industry. What we're also seeing is with car theft is that the car thefts themselves are becoming highly technical. We've also seen the relay attacks and various methods of breaking into vehicles and stealing them these days. And it's not that the car thieves have suddenly become software engineers themselves. No, they've just become tooled up, and it's where they get their tools from and how those things are engineered from the embedded systems hacking perspective that is kind of interesting, and is always where I've sort of focused a lot of research on. You can also, from monitoring that kind of scene, you also get a good feel for where things are going to go next, what sort of things these people are targeting, and where we should be putting our defenses more particularly. So there's a lot of concentration in terms of the actual problem at the user end, as in cars get stolen, there are car thieves, rather than the tools that those car thieves need to operate, and how those tools can be subverted or eliminated from the market through defensive design. So I'm kind of interested in that. If I move to the next slide and just talk a little bit about the car industry in general, and I'll just be fair to them, actually, in the past 5 years, particularly, mainly because of the Charlie Miller and Chris Valasek hack on the Jeep, there's been a much greater focus on cybersecurity in vehicles, and seen a huge uptick in activity in terms of looking at how to redesign things to be more secure. But Tesla are probably one of the leaders in terms of how they would work with the security research and hacking community. So this is a picture that I took at DEF CON 22, I think, where they came along and they were active. They were recruiting in the vendor area for their own security team. But they were the only car company at that point that bothered to turn up to DEF CON, bothered to talk to the kind of good guy hackers, and to engage meaningfully with the security research community. And I think a lot of people have had very bad experiences with the automotive industry in the past, and sort of legacy behaviors that really demonstrate how out of touch the industry was at that time, in terms of threatening security researchers and binding them with NDAs and so on. Now, thankfully, that's has dropped off considerably, and there's a lot greater engagement with the security research community. But there are still sort of legacy attitudes around the car industry and with some of the supply community that need to evolve, really, because things aren't really going to change in terms of good practice. And while I talk about legacy, one of the biggest problems that the car industry has is that they have a product that hangs around for an extremely long time. And we need to get away from thinking that, we can patch these things. We can always patch a security vulnerability, and that we need to create patches that will last for 15 or 20 years. That clearly isn't feasible and isn't possible. And the car industry needs to kind of like change its design philosophy into probably a more modular approach, which would allow for replaceable parts. Again, we've seen Tesla start to move in that direction already, but the rest of the car industry needs to start to think in that way, rather than to think that they can perpetually issue software updates forever. I think part of that is also because they haven't done it in the past. They haven't had to issue firmware updates for vehicles, and so they don't have the experience that other industries like the mobile industry do, and they haven't seen this kind of pain that comes with it. There are some advantages, of course, because the device is clearly a lot bigger, so the potential storage ability, some of those constraints start to go away a little bit. But there's some things that clearly you can't get rid of very quickly, and I'm sure you've all heard about things like the CAN bus. So the CAN bus is this sort of legacy protocol, and the network underlying the vehicles is actually it's very good, and it allows for sort of real-time communication between multiple different types of devices, and it's a standard that allows for lots of different manufacturers of components with the right dictionary of commands to be able to operate together. And that's a big achievement. CAN bus isn't just used in cars, it's used in lots of other industries. But as with a lot of legacy protocols, in the mobile industry, we are still sat with the legacy of the signaling protocol, SS7. It is very difficult to get rid of. And your industry is not just going to stop and tear up all of the old stuff because it's just not economically feasible. We have to be realistic about things. So we have this sort of period really where we have to take a bit of a sticking plaster approach, but while still recognizing that there are fundamental issues there that need to be solved. So the two biggest issues you have with CAN bus are the lack of integrity, and also so what I mean by that is that if you're inside the CAN bus network, then any message you send could be modified, and you wouldn't know as the recipient whether it had actually been modified, because the data is not encrypted in any way, and there's also no authenticity. And so that's the sort of two fundamental issues with it, and that's why people can tamper with it in some way, whether it be your Charlie Millers of the world, or whether it be somebody wanting to do mileage tampering, for example. I'll talk about that in a minute. There are new protocols being designed, and what we're seeing is deployment of automotive Ethernet, and a lot of that is on top of existing CAN bus standards. And there are other legacy protocols within the vehicle as well. There's legacy equipment in the vehicle as well. So head units and infotainment units, perhaps even from third parties, we see a lot of sort of counterfeit or Shanzai equipment, sort of substandard head units being sold for older vehicles that I really wouldn't want to put in there. And actually my company's doing some research on that right now. And what we're finding is pretty shocking. So we're finding that you've got sort of AOSP Android head units that have the usual sort of engineering passwords and so on, no security protection in there, potentially direct access to the CAN bus, and lots of other potential nasties, including pre-installed malware. And people are saying, well, this is great. It's £130. I can buy it from Amazon, and I can put it in my old car, maybe not in the one on the screen. And I get all this fantastic functionality, and it's got GPS on it. And actually, I can also have TPMS. I buy this extra bit for it, and I can put some new pressure caps on my tires, and I've also got TPMS in it. So you can understand why people buy these things, but there's a security cost that comes with it, and I don't think we've kind of hit that point where it actually becomes a real safety cost. Arguably, you can't blame the automotive industry for those things, but it's probably going to get worse in that respect if we don't start to control that in some way. But before we get to that, we also have technology moving forward in a very positive way. It's advancing incredibly, and we have new and fantastic wireless ways of communicating to other things. So what we would call V2X, so vehicle to everything, really. So vehicle to infrastructure, so to street signs, or vehicle to vehicle, things like road trains of vehicles being able to communicate with each other. Vehicle to pedestrian, vehicle to bike. You could see how these things could create great positives in terms of vehicle safety, and particularly for providing awareness for autonomous vehicles. We also have other types of technology being built into cars now. So LiDAR is the obvious one for autonomous vehicles, but we have other radio techniques like ultra wideband technologies as well being built in. And all of these things potentially could be manipulated, potentially from the outside. So we've seen examples of where, the cameras have mistaken somebody wearing a t-shirt for a stop sign. In fact, actually, we had in the UK, we had automated number plate recognition cameras in Bath going wrong because somebody mistook somebody's t-shirt as the number plate and sent the person the fine. So those are kind of real world concerns where maybe where the car is receiving that information, that the car mistranslates it, or even that the car has been deliberately targeted to mistranslate it. And that's a real concern for cybersecurity, because you're trying to fool the system. And it's very, very difficult to defend against. But of course, as we introduce all this new technology as well, everything has vulnerability. So we must pay much greater attention to cybersecurity, and components for communicating with the outside world, whether it be a telematics control unit or whether it be a cloud service that comes through the mobile network from the head unit to communicate back to the manufacturer, they've all been shown to have vulnerabilities and they've all been exploited. So the attack surface is getting greater, and what we really need is greater strength in depth in vehicles. Now, the regulators haven't stood still on this either, and the UN ECE WP29 group put together some cybersecurity requirements, and also we have a standard for cybersecurity in vehicles, which is ISO 21434, and this really lays out the requirement for people involved in vehicles to actually make sure that they carry out appropriate risk assessments, that they do proper threat modeling, and that they make design decisions based on a proper thought process. And this is something that we've done during the Secure CAV project. But it's, don't get me wrong, threat modeling is the right thing to do, but it's a very, very tough challenge. And you've got to get the right people in the room. You've got to make sure that you've got people who both understand the threats, the real world threats that are in the market, who are actively going and purchasing that equipment and understanding how it works. Plus, you need the design engineers who actually understand exactly how the car works and what's feasible. And then you kind of need to somehow get them repeatedly in a room together and actually brains engaged. And that's the problem. This is a very, very human task. There are many tools to try to automate threat modeling, but at the end of the day, you're going to come down to this human task, and it's time intensive, it's brain intensive, and it's difficult. And people aren't willing to share their threat models either. So that's the other challenge we have, is that people are developing these things in silos. So it's a challenge that we face going into the future, and companies, we're all human, and the miscategorization of risk, either through not understanding the threat that's being posed, or through just simple tiredness in the process, is very real, and that could cost companies a lot of money, either sort of putting the padlock on the paper bag, spending too much on security when you don't need to, or equally just not putting the security in the right place. So coming back to what I was saying about the security research community, I'm very passionate about ensuring that we don't exclude the people who are the most passionate people about cars. And that's really the car modding community, the car fans. And you'll see them, the most people who use the Torque application, for example, with the OBD2 dongle, they're big car fans. They're a fan of that particular manufacturer. They're not the enemy. It falls into that line of, where does tampering and where does hacking stop? If I remap the ECU on my car because I want to reduce the tolerances because I want to get it faster, well, I am technically hacking that car. So what we need to do in the automotive industry is come up with a way that we somehow facilitate that community and don't alienate them, because actually, if you do facilitate them, it will reduce the amount of successful hacking in a market. And the reason for that is that if you open up APIs within a limited fashion that do what those car fans want, they're not going to be spending their own money trying to find a solution for that from the sort of underground community, which is what happens. It's the same thing that happened with the sort of SIM locking thing on phones. The picture that I'm using here is a group of car fans, realistically. So if you look at Carroll Shelby's Shelby American team that won the 1966 Le Mans, that was basically a bunch of car modders. So let's not leave those people behind. Let's not leave the car fans behind. Let's find good ways of opening up cars to third-party development in an authorized way, but in a sensible way. And that actually ultimately will reduce hacking. So onto some of the use cases that we picked up in this project. So one of the things that we wanted to look at was mileage tampering. We had a couple of vehicles that were loaned to us by Which, the consumer organization, which is fantastic. We also bought a lot of hacking equipment and reverse engineered it. And during that process, which by the way happened during COVID, so it was very difficult for the parties to work together because we all had to independently buy our equipment. Coventry University were building a demonstrator, but they couldn't even get into their buildings. So it was a very challenging process. What we decided in that process, we build our own demonstrator, our own hacking demonstrator, because we had no other choice. And what we realized was actually we could use the mileage tampering equipment that criminals are essentially using on real car equipment, but send telemetry from what are essentially simulators or games into something that then translates that into the CAN bus data, and then actually start to see how the mileage tampering worked. And we could do that on other components as well. And we started to build up this kind of working rig. So we were able to build this sort of rig that didn't mean that we were breaking the law. And it didn't mean that we had to break COVID rules or anything daft like that, or spend lots and lots of money going onto a test track. But we were still as effective in our reverse engineering. And also, as we found out, being able to test out different scenarios. So actually, we were able to test out different sort of safety related scenarios. So I decided to put some switches in to cut the brakes at any point. And so we built a simulator where you can sit in there and you can experience exactly what it's like to have your brakes removed at 100 miles an hour. And we've actually got a motion platform to do that. I'll show you in a minute. And it's truly terrifying, I've got to be honest. When you're completely out of control like that, and you're going to hit a wall or something. And so we started to develop this more and more, and we started to build in various bits of hacking equipment. You can see here the OBD2 interface, that we did a survey of different types of dongles out there. Some of these things are used for spying. Some of them are used for sort of vehicle maintenance tasks, but quite interesting. And also interesting is where companies have tried to build in OBD2 security gateways, that people have subverted those fairly quickly. So it's quite interesting to sort of see how those defenses are broken. Head units I've already spoken about. Door locks are obviously of concern for car theft. This is an example of some of the reverse engineering we're doing. So this is one of the mileage tampering devices. So they know that people are looking at this. Maybe they don't want their own stuff copied because they scraped off the chip details there, you can see. And relatively trivial equipment to reverse engineer, but quite interesting nonetheless. And really, if you're in the car industry, then you should be buying this stuff and you should be looking at it because you want to know what your adversaries are doing. What we did in the project is we have to think about what the attackers are going to do next. So what we were trying to do and what Siemens were trying to do was build in monitoring and detection capabilities. So once we reverse engineered that equipment, or even if we've never seen that equipment before, can we detect it if it's ever used, and can we recover from that? Combined with other security techniques to secure the CAN bus, for example. And we showed that it is possible to detect the hacks that we were looking at. And so we have to think beyond that. We have to think, well, how would somebody attack the monitoring system itself? And how would we defend that? How would we be able to get the data off the car if the attacker had some control over that? So that's some of what we've been thinking about in the project, and we've produced some materials and white papers on that. And we have this demonstrator that we've built. But realistically, what this really means for the long term is that the defensive measures have to be adaptable and have to adapt within a hostile environment, because your attacker is going to move as well. And so we have to think about what the attacker's next steps are. And that's really what we're concentrating on, and we'll be concentrating on in the future. This is the rig. You can see the motion platform here. We'll actually be at B-Sides London at the back end of next week, which will be the first sort of public outing of this. And you can come and you can actually go on the rig. What's not shown here is the set of controls where you can take control of the steering, and you can take control of the brakes, and really scare your colleagues. So do come along to that if you're attending. We'll keep working on this. You might have also seen that the sort of sweating the assets, as it were. We've obviously the automotive industry is interested in car racing, and so am I. So we've taken our hacking rig, and we actually compete in a GT3 Esports racing league. And we have a liveried vehicle there. But it's really, really interesting, and we'll keep doing that and keep really sort of promoting cybersecurity for future vehicles into that world, which there are a lot of real racing drivers that race with us. So it's super exciting, and I'd love you to come and watch some of our racing on Twitch sometime and talk to us about what we're doing. So that's really the sort of short version of things that I could tell you at the moment. You can download the white paper from the Secure CAV website. We're going to keep working on this. We love doing it, and there's loads of hacking equipment out there that we want to reverse engineer. So so any suggestions, just email me or contact us on the website. So that's it. Thank you very much.